Good morning, students. Yesterday, we have seen the potential of a particle. Today, we will see the gravitational potential at a point outside the solid sphere. Gravitational potential. Gravitational potential at a point outside this sphere. Outside this sphere. For this, we consider a sphere of mass m. Suppose this is that sphere. Its mass is m, and its mass is m, and the center is O. Suppose the point is situated outside this sphere. Then we can calculate the gravitational potential due to this mass m on this particle p. For this, we will let us consider a body having mass m is at O and point P be outside this sphere. If the particle is at infinite distance, then potential is 0. If particle is at infinite distance, then V equals to, where V is the potential, V equals to 0, and the gravitational potential at a point, in the gravitational field of a body is the amount of work done on the unit mass. Therefore, now let us consider a sphere is divided into large number of cells. That cells is like this. Suppose this is divided into the large number of cells like this. This is the large number of cells. Then we have to find the potential due to all these cells. Then the potential, as yesterday we have calculated the potential at a point due to the mass m. Similarly, in this topic, we have to calculate the potential on this point P due to all these cells. Therefore, the potential at point P due to this cell number 1 is V1 equals to Z1 minus Z into M1 upon, where M1 is the mass of the cell and R is the distance between this cell and this particle P. In this way, we can write or calculate the potentials for second cell, third cell, fourth cell, and so on. Therefore, the potential due to this second cell on this particle P is minus Z into M2 upon. Like this, we can calculate or V equals to minus Z into M3 upon. In this way, we can write the potential. Now, we want to calculate the potential, overall potential or total potential due to all these cells on this point P. That can be calculated by adding the potential due to these cells. Therefore, V equals to V1 plus V2. That is the total potential P due to all these cells is given by V equals to V1 plus V2 plus V3 and so on. This can be written as V equals to minus Z into M1 upon R minus Z M2 upon R minus Z into M3 upon R. Here we can take Z upon R as common. Therefore, this can be written as V equals to minus Z by R is taken common, and the remaining part we have to write inside it, where this M1 plus M2 plus M3 is the total mass of this sphere, where this total mass of the sphere, and that mass is considered as the capital. Therefore, we can write here the potential due to all these cells is equals to minus Z into M upon R, and this is the potential due to all these spherical cells on this particle P, which is located at outside the sphere. Now, the next point is potential at a point inside the solid sphere. Potential that is gravitational potential. Gravitational potential at a point inside the solid sphere. We are calculating the potential on a particle outside the, or already we have calculated the potential on a particle which is located at outside the sphere. Now we are calculating here the gravitational potential at a point inside the sphere. For that, we will consider a sphere, a hollow sphere, or sphere like this, and this sphere is made up of hollow spheres that can be shown like this. Suppose the point P is lying inside the solid sphere at the distance equals to R. This is the center of this solid sphere, and this is the radius of this solid internal solid sphere. Now, this is the radius of this solid sphere. Now, and this part this is the dx that we will explain it somewhat later here. Now let us consider r be the radius of the sphere. Radius of the sphere, this r is the radius of the sphere and m is the mass of the sphere. Now let the point P will be lying inside the solid sphere. The distance between center O and point P is r. This is the distance between this point P and this is center OR, that is r. And the volume density of this sphere is rho. The volume density of sphere is rho. Now, the solid sphere was made up of a large number of hollow spheres concentric with it and with their radii ranging from R to capital R. Point P lies on the surface of the solid sphere of radius R, and inside all the cells of radii greater than R. The potential at point P due to the inner solid sphere of radius R is given by V1 equals to minus mass of the sphere upon radius R into G. This is the equation number 1. What we have done here, we have considered this sphere is a hollow sphere, which this sphere is made up of a hollow spheres like this. Suppose this is the outer sphere, then another hollow sphere is here, then another hollow sphere, like this. This solid sphere is made up of a hollow spheres, and we have considered this one from it. But the mass of the sphere equal to 4 pi, mass of the sphere equal to 4 by 3 pi r square pi r cube. This is the formula for the mass of the sphere. But we know that the potential V1 can be, or we can put this formula here in this equation number 2. Therefore, equation 1 becomes, here mass of the sphere, this is the mass of the sphere, that is 4 by 3 pi r cube rho divided by this r into g. This 1 r will get cancelled with this, and this is the V1 equals to 4 by 3 pi r square rho. This is equation number 2. This is equation number. Now, to determine the potential at P. To determine the potential at P, I will make this. To determine the potential at P, to determine the potential at P due to the outer cell, to determine the potential at P due to the outer cell. That point P is here, and we want to calculate the potential at this point due to this outer cell. Okay. Then for this we consider a cell. Consider a cell of radius x and thickness dx. that cell is this cell. Okay, for this cell the radius is x from O to this up to this. This is the radius of this cell, and the thickness of this cell is dx, that is shaded part shown by the shaded part, that is dx. Now with this we can calculate the x and radius dx. Volume of the, therefore its volume can be written as volume of the cell, volume of the sphere. That cell is just like a sphere, therefore we call it as a sphere. Therefore surface area of the sphere into thickness is your surface area of sphere into thickness. The surface area of sphere is 4 pi x square and thickness is dx. Therefore this is the volume of that sphere. This is equation number 3. Now, and its mass is, now we will calculate mass. Therefore the mass equal to, mass is mass of the sphere, mass of the sphere, mass of the sphere four pi r square means x square into density, that is rho, and the thickness dx. This is equation number 4. Now from this equation we get the volume of the sphere, from this we get the mass of the sphere. Now we can calculate now the potential. Then equation 1 becomes the potential at P. Then potential at P, potential at P due to the inner solid sphere, due to the inner solid sphere due to the inner solid sphere of radius is equals to minus 4 pi x square rho dx upon r into g, and this is equation number 5. I think we'll stop here. The remaining part of this equation we'll see in the next period.